One of the most important concepts in Python is mutability, whether an object's value can be changed after it's created or not. In Python, we categorize objects into two groups, immutable and mutable. Immutable objects cannot be changed after creation. Typical examples are numbers like integer, float, strings, and tuple. When you change an immutable object, you actually create a brand new object and bind the name to that new object. So mutable objects can be changed in place, like list, dictionaries, sets are common mutable types. Mutating these objects modifies the object itself. Any name that refers to the same object will see the change. So let's walk through the concrete examples so the difference is crystal clear. We will also cover important consequences like identity versus equality, function arguments, plus equals to behavior, shallow versus deep copies, and a few classical mutable default arguments. So here are some simple examples considering integers and lists. Code block 1 deals with immutable type like int. X and y initially point to the same integer 10 object with 10 value. X plus equals to 1 creates a new integer object with 11 value and rebinds y to it. Notice that x still references to the original integer with 10 value. For immutable integers, when you do x is equals to 10, y is equals to x, both names reference the same integer object. But if you do y plus equals to 1, Python creates a new integer and rebinds y to it. X still points to 10. You can confirm this by checking with the help of function that is named as id. So id x and id y. id basically returns the object's memory addresses. For example, mutable list, if a is equals to 1 to 3, b is equals to a, both name reference the same list object. If you call b dot append 4 and list object itself is modified, so a and b both show 1 2 3 4. Their id values remain identical because it's the same object. This difference matters when you pass objects into function. If you pass a list and a function mutates it, the caller sees the mutation. If you pass an integer and the function changes it, the caller doesn't see any change. The function simply rebinds its local name to a new integer object. Here we can see the Python built-in data types, which of them are immutable and which are mutable. Starting at the top, numeric types like integers, float, booleans, and complex numbers are all immutable. Once created, their value cannot be changed. When you perform an operation like x is equals to x plus 1, Python actually creates a new object with the updated value and rebinds the variable name to it. Next, tuples, strings, and frozen sets are also immutable. Tuples can hold different objects, but you cannot modify their structure. You cannot append, you cannot remove or reassign elements inside them. Strings are immutable sequences of characters. Any operation that looks like it modifies a string, such as concatenation, slicing that we will be covering later on, or replacing a character, always returns a new string object. Frozen set is simply a immutable version of a set. Once created, its contents cannot be changed. On the mutable side, we have lists, sets, and dictionaries. These can be changed in place, meaning you can add, remove, or update their elements without creating a new object. The same list object now contains 4 elements. The variable a still refers to the same memory location. You can verify this again using an id function on a before and after the append operation. Similarly, sets allow adding or removing numbers dynamically, and dictionaries let you update key value pairs on the fly. It is important to remember that immutability brings safety and predictability, while mutability brings flexibility, but it also potentially has some side effects, like if multiple names refer to the same object. So when designing your own class or choosing data structures, think carefully about whether your data should change in place or remains constant once created. Notice how the string x changed its identity. A new object was created. while the list kept the same identity, meaning it was updated in place.